whenever two functions are multiplied, okay, and then the question is asking you to find the nth derivative of that multiplicated expression, it's then that you have to apply the Leibniz theorem, okay? So what I mean is, look at here, Leibniz theorem, okay? If you find a function that has a multiplication of two functions u and v, okay, when u and v are two different functions, and if they are multiplied together, and if they're asking you to find the nth derivative of this entire multiplicated expression, you have to apply this formula in order to find the nth derivative of this expression. This is nothing but the Leibniz theorem, okay? So you either denote the nth derivative with d power n and uv, or you can also denote it, denote it like u into v subscript subscript n, okay? It's up to you, or whatever you want, you can denote it. There are two ways of denoting the nth derivative. So whenever you find two functions u and v multiplied, and then they're asking you to find the nth derivative, so apply this Leibniz theorem and find it, okay? So let's start with the first question. In this video, I'm going to solve this one question. In the second video, the next video of this playlist, I'm going to solve one other question regarding Leibniz theorem. And in the third video, I'm going to solve the third question, okay? So make sure you subscribe the channel so that you can stay close to all my future videos and content, okay? So make sure you watch all these three videos in this playlist of Leibniz theorem. So the first question from the Leibniz theorem is, these three videos that I'm going to make regarding Leibniz theorem is more than enough for you to get a complete understanding about Leibniz theorem. And of course, I'm going to give you several practice questions in the description of the third video, not in this video. Watch all these three videos. In the description of the third video of this playlist, I'll be giving you all the practice questions. I'll be giving you many practice questions, don't worry, with solutions, okay? So let's learn, first of all, what is Leibniz theorem. The first question, let's say x cube into 4 power x. Can you clearly see that x cube is u, okay? U is x cube, and then v is 4 power x. So two functions are there. Both are the functions of x's, okay? Both has x as the variable. So u and v both are function of x. So x cube and 4 power x are two functions u and v, and they're multiplied together. And the question is to find the nth derivative of this entire expression. So you have to apply the Leibniz theorem. So u, in place of u there is x cube, in place of v there is 4 power x. So u will be x cube and v will be 4 power x. Okay, and this is the formula. uvn plus nc1 un v n minus 1 plus all the way it goes on. There are many terms. You have to keep doing this until you reach a point where un into v. That will be your last term. I'll tell you when to stop and which will be the last term in this question, don't worry. So let us start solving this first, okay? So u and v, we know how to get it, okay? And then now, can you see there are different, you need u1, u2, u3, u4, so on till un, and then you need nc1, nc2, nc3, nc4, so on. And then you also need vn minus 1, vn minus 2, vn minus 3, so on, to find the final answer. So let us first individually find the values. Let's find u1, u2, u3, nc1, nc2, nc3, and so on. vn minus 1, vn minus 2, vn minus 3, so on. Let us find it individually first. And then once we get all the values, let us put in this formula and find the nth derivative, okay? So let's start with u1, okay? Let's start with u1, okay? u1 is nothing but the first order derivative of u. That's what u1 means, okay? Yn means nth derivative. So that's what the question says. Find the nth derivative, okay, of y. Y is this. u1 means find the first order derivative of u. What is u? X cube. So differentiate x cube. What is the differentiation of x cube? Differentiation of x power n. The very basic formula which we learned in 11th and 12th standard calculus. So n into x to the power n minus 1, right? Yeah, so this is a basic formula. So let's apply this here. By the way, all the basic differentiation formulas are given in the description of this video. Don't worry, okay? If at all you haven't taken mathematics in 11th and 12th standard, I agree. I understand you wouldn't be knowing all this. So all the basic formulas of differentiation I've given in the description. Those formulas are more than enough for you to solve any question. So let's apply. In place of n, there is 3 and there is x. Okay. So n into x to the power n minus 1. 3 into n minus 1, n minus 1. 3 is n. So 3 minus 1 is 2. So this is u1. Okay. We found u1. Okay. And then we need u2 as well. Okay. So u2 is what? What is the meaning of u2? u2 is the second order derivative of u. First order is when you differentiate it once. Second order is when you differentiate u1, you get u2. u3, when you differentiate u2, you get u3. When you differentiate u3, you get u4. So it's like that. It's recurring. So u2 is nothing but differentiation of u1. Okay. So again, differentiate this. 3 as it is constant, x square again, n into x to the power n minus 1, 2 into x to the power 2 minus 1. 2 minus 1 is 1. So x power 1. Okay. So that's what, this is nothing but 6x. So this is u1, this is u2, and then u3 will be what? u3 will be only 6. Differentiation of 6x is 6. And then u4 is what? u4 is nothing but differentiation of 6. Okay. u3 is differentiation of u2, u4 will be differentiation of u3. u3 is 6. 6 is a constant. So differentiation of any constant would be 0. So since you got u4 as 0, where is u4? See, u4 is here. And u4 is 0. And there is multiplications here. So you can clearly say that this particular question will have only till this term. It will not have this term because u4 is anyway 0. So u5, I mean the next term, whatever comes, after this will all be 0, 0, 0, because differentiation of u0 is always going to be 0 because 0 is also constant. So I mean u5 will also be 0 because differentiation of 0 is 0. u6 also will also be 0 because differentiation of 0 is 0. That's what I meant. So this particular question will have only this term, this term, this term, and till u3. Till u3 it will have. From u4 it will not have. So it will have only these. So it will have only these many 1, 2, 3, 4. 4 terms this will have. From this term it will not have because u4 is anyway 0. Okay. So that's how you come to know where to stop, how many terms it has. Yeah. So u4, yeah. So u3 is last. Yeah. And then that's all with u. Now let's go to v. Okay. So what is vn? Vn is what? What is v? 4 power x, right? So isn't this in the form of a power mx? Yes. Now what comes to your mind when you see a power mx? In the previous 2 videos where I taught a standard, nth derivative of standard function, we saw this example clearly. So if you haven't checked, I given the description, a link of that standard function, nth derivative of standard function in the description. Please go watch it after this. So the formula is when y is equal to a power mx, that's what it is. Y is equal to in the form of a power mx. This is the nth derivative. So Vn is what? Vn is nothing but find the nth derivative of v. V is in the form of a power mx. So let's apply the formula here. Formula says that if y is equal to a power mx, that implies that nth derivative, okay, you can either denote nth derivative like this or like this, not a problem. Nth derivative is given by the formula m into log a to the power n a power mx. Let's apply this formula to v and find vn. In place of m, there is 1, right? If nothing is there as a coefficient, that means it's 1. So in place of m, it's 1. In place of a, we have 4. Okay. So we have a as 4 and m as 1. Okay. For vn. This is to find the vn. Yeah. So vn would be just substitute a 4 and m1 in this formula and find the nth derivative of vn. So the nth derivative would be what? Yeah. So it would be log 4. Okay. M is what? 1. So 1 into log a. A is what? 4. So log 4 to the power n into a. A is what? 4. 4 to the power mx. So just x. M is 1. So only x will be there. So this is, okay. So this is Vn. Okay. Since we know Vn, very easy to find Vn minus 1, Vn minus 2, Vn minus 3. Why only Vn minus 3? Because from Vn minus 4 it's not required, because I told you U4 is anyway 0. So this question is going to have only 1, 2, 3, 4 terms. From this term it's not going to have. Yeah. Quickly let us find V of Vn minus 1. How to find Vn minus 1? If you know Vn, finding Vn minus 1 not a big deal. Wherever you see n, put n minus 1. If you want to find V of n minus 2, Vn minus 2, wherever you see n in the Vn, put n minus 2. Okay. Log 4 to the power, what did I say? In place of n, put whatever your desired order derivative is. In this case, it is n minus 1th order of V. So in place of n, I'm putting n minus 1. Okay. So 4 into x power n. So this will be, yeah, Vn minus 1. Now we also need Vn minus 2 and Vn minus 3 for this particular question I'm talking about. So Vn minus 2 would be what? Wherever you see n, put now n minus 2. So log 4 n minus 2 into 4 power x. Okay. Similarly, find V of n minus 3 would be log 4 to the power, in place of n, put n minus 3. N minus 3, 4 power x. Okay. Now we have found C1, C2, U1, U2, U3 we have found. And then we have also found Vn minus 1, Vn minus 2, and Vn minus 3. So the only left out is find NC1, NC2, and NC3. Okay. Now how to find NC1? NC1. What is the formula for NCR? NCR is equal to n factorial by n minus r factorial into r factorial, right? This is the formula, NCR formula. Now in place of r, there is 1. So let's apply this formula, n factorial by n minus r is 1 here. So n minus 1 factorial into r factorial. So 1 factorial. How to solve this? What is the meaning of factorial? If I say 5 factorial, what does it mean? It means 5 into 4 into 3 into 2 into 1, right? That's what factorial generally means. You start with the number and then go all the way up to 1, having multiplications in between. 5 into 4 into 3 into 2 into 1. That's what 5 factorial means. So basically what you're doing, considering 5 as n, okay? So you're putting n first into 4 is what? 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 4 is 5 minus 1 is 4. 5 minus 2 is 3. And then 5 minus 3 is 2. 5 minus 4 is 1. So you're basically going like n into n minus 1 into n minus 2 into n minus 3, n minus 4, so on. Right? Yes or no? I'm just giving you an example with 5. Now there is n factorial. In place of 5, there is n. So just try the same thing. N into n minus 1 into n minus 1 factorial. I'll stop it as. Why? Because this will keep going. N into n minus 1 into n minus 2 into n minus 3 into n minus all the way till 100,000, 10,000. It's an infinite thing. Okay. See, when there was a number, we know where to stop. We stopped when 1. We arrived at 1. Okay. N minus n into n minus 1, n minus 3, n minus 2, n minus 4. Okay. That's how. Since it was a number, we knew where to end it. But here there is only n. N is not a number, it's a variable. So that's why I'm stopping it from n into n minus 1 factorial. This simply says that this will keep going. N minus factorial is again what? N minus 2 into n minus 3 into n minus 4 into n minus 5. That will keep going. So to stop that infinite loop, I'm just representing it with n minus 1 factorial. By. Again, in the bottom denominator, there is n minus 1 factorial and 1 factorial is 1. So n minus 1 factorial and n minus 1 factorial will cancel, and then remaining would be n by 1, which is nothing but n. So NC1 is n. Okay. Now similarly, let's see how to find NC2. NC2 is what? Again, n factorial, same thing only, n factorial by n minus 2 factorial into 2 factorial. What is n factorial? N minus 1 into n minus 2 into n minus 3 factorial. into n minus 2 factorial. See, in the previous question, I stopped it with n minus 1 factorial so that I can cancel it, so that I can simplify it and reduce it to n. Okay. In this thing, I'm stopping it with n minus 2 factorial. Okay. So that I can cancel this and this. That's how you form it in the way to solve it. Yeah. So 2 factorial is only 2. So the remaining is n into n minus 1 by 2. Yes. And then quickly let's find the NC3 now. Last one, okay? This is last. NC3, okay? That will be n factorial into n minus 3 factorial into 3 factorial, right? So what is n factorial again? N into n minus 1 into n minus 2 into n minus 3. I'm stopping it here by putting a factorial for the last term. By n minus 3 factorial. Why I did this? Because to cancel this sense, to reduce it. And then 3 factorial is 3 into 2 into 1. That's what 3 factorial is. So this is nothing but n into n minus 1 into n minus 2 by 3 into 2 is 3 into 2 into 1 is 6. So this is NC3. Now we have found everything required. We know U, we know Vn, we know NC1, U1, Vn minus 1, everything we know. I mean, again, I'm repeating. Since U is, since U4 is 0, this will only have U3 till U3. U3 is here. So it will only have 1, 2, 3, 4. These 4 terms it will have. It will not have after this. For this particular question, this might differ for different questions. Again, I'm going to solve 3 questions in this playlist. So this is the first question for the video. Subscribe if you haven't subscribed the channel. Yeah. So we know everything now. Okay. We know everything we know now. So let's put all the data here and finally find the nth derivative of y. Okay. I'm not going to take much of time from now because I'm just going to substitute everything there. So I'll do it quickly. So finally, okay, one quick tip, okay, one very important point I missed. Always, right, when I'm solving a Leibniz theorem question, right, always begin with finding u's first. U1, U2, U3, all the u's, okay? And then you can go to all the v's, and then you can find NCRs. Okay, always start with finding the u's, U1, U2, U3, because only then you will know how much terms, are going to be present in a solution. See, I began this question with finding u, and somewhere at some point u4 was 0. So this clearly said me that it's only up to u3. So u3 is here, so it's only going to have only this part of the expression. From u4, I mean from this expression, it's not going to have. So that's why it's a good practice when you're solving Leibniz theorem. Always begin with finding the u's first. Okay, by that you'll know how much to solve, how much terms you will have in the final answer. Otherwise, you can make mistakes. After finding the u's, you can go for finding the v's, and then you can gradually find the NC1, NC2, NC3, NCR, and all that. Always begin with u. Okay, that's all. Yeah. So quickly substituting the formulas here and then trying to get the yn. Okay, let's find the yn now. After substituting all the formulas, you'll finally get yn as x cube log 4 sorry so yn would be x cube into log 4 to the power n into 4 power x plus n into 3x square into log 4 n minus 1 into 4x plus n into n minus 1 by 2 into 6x into log 4 to the power n minus 2 4 power x plus plus n into n minus 1 into n minus 2 by 6. Okay. By 6 into 6 into log 4 of n minus 3 into 4 power x. So this will be our final nth derivative of the given question, x cube into 4 power x. So this is the Leibniz theorem. Hope you got it everything. So I'll see you in the next two videos where I'm going to solve two more questions. With these three questions, we'll be pretty much done with everything. And in the description of the third video of this playlist, I've given many practice questions. So you can either glance through it or you can solve it. No problem. It's more than enough. So that's it with this. So I'm also a freelance trainer where I teach full stack development, backend, front end, backend, and full stack development, and all these programming languages that you see on the screen right now. So if you're interested to learn personally from me to optimize your learning path, to optimize your learning journey, in the description of this video, I've given an email ID. So please send an email regarding your interest or whatever inquiry is regarding my training. Please send it. I'll immediately reply back and we'll start with the training immediately as soon as possible. Okay. So the email ID is in the description below. So I'll see you in the next two videos of Leibniz theorem. Stay tuned. Thank you so much.